I have a meeting. Whoa, when is that meeting? 1 second. What's the time? It might be really, really soon. I wouldn't be shocked. Yeah.
What time is it?
11. Design time. We're not counting the episodes anymore. One cool story, the guy that actually, he saw one of my videos, he worked on / made the parts for this NASCAR, and he messaged me on Instagram. So if you're watching this video, it's cool. It's pretty cool. His whole profile is about being on this NASCAR team. Secondly, we're working on Cleetus McFarland's Garrett's Cadillac Blackwing CT5.
I've been working with Josiah over at FDF, and he actually has an entire scan of one of these cars, and he's been designing a full custom angle kit, not only to give him maximum lock, but this guy wants to keep stock fenders, which makes it a little bit of a challenge. So you're not gonna have crazy wide wheels.
Yeah.
Because to get the steering lock and not run into stuff. It's pretty exciting. Josiah is a super, super intelligent guy.
That guy is crazy. I follow him on Instagram. I'm like, some of the stuff he makes is nuts.
Yeah. So the goal is he's gonna get us some parts. We'll be able to install them. We'll do the handbrake. If you want bucket seats, we'll get you some bucket seats.
Sure.
We got the OEM CAD for it. Bonus and some useless information for you guys. If you didn't know, the subframes for the CT5 and the Camaro Gen 6 happen to be the same subframe. And I actually found this by necessity because we did not have the subframe for the Cadillac. And going through some AI endeavors, it determined that 3 GM cars actually share this subframe. And we found it. I was able to get the CAD file for that. I dropped it in place, and sure enough, she fits. So that's really cool. Bit of information that no one in the world would ever need to know other than like 3 people. Moving on from that, we have simulated the OEM suspension for the Cadillac CT5 and all of its motions and movements. It's really a lot of information. That's why it's fairly glitchy. And also these sway bars, the ones that go to the strut, they really, really mess things up. So you can actually see as I articulate this, as I'm turning, it's actually compressing the shock on the opposite side. And that's because in order for this system to actually work, the sway bar will actually need to twist. And since we're not doing that in this simulation, it requires me to allow for it. So these simulations are tough. If you put the sway bar to the control arm, much, much smoother. Again, more useless information that you might never use, but we're going to be getting rid of this double control arm design, replacing it with a single lower, single pickup point. I'm going to make an adapter on this knuckle. I'm not sure what I'm going to be picking up on using it, but basically we need to relocate the tie rod, give a new pickup point for the control arm, set all of our parameters and design criteria up for the alignment specs. I looked up the OEM alignment specs. We'll probably maintain something similar to that, other than the camber is obviously going to have to be more. They specified that they wanted it to be within the OEM fender, so that's going to be tough. You can see how short the control arms are, so whenever the control arms are short, it means the subframe is wide. The wheel is going to run into the subframe fairly quickly, so we're going to have to select a fairly narrow wheel, fairly narrow tire, and a lot of things got to come together. So the idea is to simulate absolutely everything and come up with a product that we can then bring to Florida. I'll probably be flying down there, and we're going to do some secret things to the kit that I think Cleetus is going to love. Next up is more awesome stuff. I'm going to be showing you guys a couple products that we're going to be releasing. All of it is anodized aluminum goodies, and I'll kind of build it for you. Your camera can see this, Jay?
Yeah.
The one that I'm most excited about actually is a universal brake biased booster delete kit. We have notoriously sold this for the Corvettes. It's done really well. We sold a lot to road race guys. So the way that I went about this was I want to make a modular universal one. So we made this plate. This is a firewall universal plate. Essentially there's no holes in it, and you could put this and join it to your firewall by drilling holes. A lot of boosters are 2 bolts, 4 bolts. The next thing is this is going to be the universal build your own billet dual master kit, where essentially you're going to assemble these 3 pieces together. And once you tighten this bolt, you now have a master cylinder mount. And I'll bring it up here so you can see what I'm doing. This is the assembly here, so you can see how it's going to be working. With the swing arm, your pedal is going to push here, and it will give you a ratio increase and then a bias bar to dual masters. The reason we're doing it this way, billet, is because it's nice and repeatable, but the mounting design is also universal. So as we design products, we're going to make these plates specific to cars throughout the process while maintaining a universal option. So for any car, you could just buy this plate, buy this kit, and basically make it work. But as we learn more about each chassis and what each chassis needs, we'll make a specific plate. Like we've already made a specific plate for an IS 300, for a BMW E3646, for a Corvette. So we're going to go through our paces and do that using the community, because guys are going to buy the universal one, and then we're going to learn what it required to make happen. So it's a win-win. The swing arm goes in place. We have a nice shoulder bolt that ties this in, and essentially this will swing and press the master cylinders like you can see on the screen. So we are stocking up on these things because they're going to be FD legal if you're watching from a drifting perspective, and then for everyone else that does every other type of motorsport, obviously this is going to be fine for you too. So we'll put that over there. These are drag racing C6 anti-squat brackets. They basically locate on the rear factory camber slot, and then they give you a new position at a higher location, increasing the anti-squat percentage further. Great for drag guys that want to improve their 60. And yeah, it's just going to be ideally designed for drag. And then for drift, we could sell these and you can use the lower hole and it just drops the percentage. The reason you want to lower it a little bit for drifting, give you a quick insight, depending on the track, the anti-squat percentage on a Corvette for drifting is a little bit high, and it actually ends up locking out the suspension's ability to travel and absorb bumps, and you end up losing traction while in drift over, depends on the track, like I said, but I've found from driving a Corvette that slightly under OEM is the better location. So this could serve for those. The next thing, we designed this uniball. You've seen our shim design. This is a prototype. This is basically taking the 2-hole pattern and rotating it horizontally. Different applications require this design. So this is a pretty sleek looking piece. Uniball bearing goes in. Then we can design a control arm from here and have the same shim adjustment with that. Just racking them off. The next thing, we've had this on our BRZ for well over a year. Dual caliper brackets for the BRZ. These work great, so we're pretty much just gonna release these ASAP. We do have stock on them now after getting them back from anodizing. They look fantastic. Nice laser etched passenger side, driver side, making it simple. That really is it. I mean, this kind of turned into a product release thing. And then I think you guys saw this. This was the BMW control arm that we used a outer tie rod to then adapt it to a sleeve and then a heim joint. So now it becomes an adjustable control arm using the tie rod. Tested this out on the E82 ice drifting. We lengthened it over like almost 40 millimeters longer than the OEM one. Used our eccentric bushing on the tension arm, and it worked really, really well. Gave us so much clearance that we actually weren't hitting anything. So now we're running an angle kit that gets like 50 degrees of angle with the dual ball joint design still, and I actually wouldn't want any more angle than what this car gets. Really impressive, and I'm comparing it to currently an F80 control arm, so it looks like it's going to work for that as well. BMW did something cool. They used the same ball joint stud on every single car from 2007 to present. So if we come up and engineer a very good ball joint, which I've been toying with all kinds of different ideas, this would be us actually making our own ball joint where we would machine this stud we would machine the housing, we would make a nylon insert, and then we would install this cap on the back and lock it in. And this would be an actual ball joint for the BMW with essentially bump steer correction, so we can put shims between the shoulder and here. But designing this and then 3D printing it, there is too much going on here for us to take on right now. So designs like this, it kind of shows you'll spend, there's so many parts and hours going into products like this where you'll never see it. We design these products all the time and then only half of them get released. This one, currently with our machine setup, it's just too intrusive, but some cool 3D printing tips that we can take from it and assembling it and tolerances. This is a stem with a ball printed in 2 halves using alignment dowels. So this actually is a much cleaner way to print round objects, is slicing them in half, printing them both down, and then using alignment dowels. So that was a cool trick. I did already know, but I haven't gotten to use it that many times. That's pretty much all I have for this one. Rain's got the 370Z lowers. Did you grab one, Jack?
No, they're getting powdered.
No
Might
way.
be done powder now.
No.
That was before lunch.
Run. They were in the oven?
They were just getting sprayed.
Oh, there's no way they're done.
Yeah.
Black. Oh. Well, that's the new lower for the 370. It's kind of like a BMW, but it has to go over a tie rod right here. And you'll even notice that the shock mount is actually on a 8-degree angle here. This is a great job. Rain busted this out. I'm not convinced that this brace was actually needed, but we put it there to support because we had to make it so narrow here for wheel clearance. But this is a really clean, really nice control arm. It's going to improve the process of that kit, ultimately make it a better product. So there is a point of going back through. Now we've been selling that kit for like 5 or 6 years and it's been working great. But applying what we've learned over time, manufacturing wise and performance wise, there's always a way to do something better, even if you're a rocket scientist. So nobody's exempt. The rockets today are definitely better than they were before, and those are to be. I don't know why I can't talk today. That's considered to be the pinnacle of engineering. So yeah, we're making an improvement. We're going to test it on our G37. Now that's all I have to go over. That's all I have to talk about. And we're doing ice drifting this weekend, so Jack will probably post about that. We're doing some crazy studs. Yeah, it's been busy. It's been busy. So we'll see you guys on the next one. Bye for now.